Hello and welcome to another free code session. My name is Jason Bach, and it's been a while since I've recorded an episode because I've been doing a lot of work to get to. Let's zoom in on it here. 8.0.0 Alpha 1. I said that wrong. I did 0. It's been a lot of work. I'm tired. No, I have been spending a lot of time though on rocks off camera over the holiday and some other nights and getting some other things done. It just took forever to get the new changes in, but I think it's been well worth it. I've done some benchmarking already because I had to update benchmark MockNet, or at least I offered to do the PR for it. So I've got a draft PR in place right now, and I'll come to that in just a moment. But the overall results are good, and there are two things that came out of those benchmark tests that I'm like, I think I know how to address those as well. So I'm very happy with the results that I have. I'm very happy with all the effort that's been put into place, that it led to a place of fruition. You know, I really tried to make sure before I went down this road that this idea would reap some benefit, because I knew it was going to take a lot of work, maybe not as much as I put into it, but all the tests would have to be altered. All the tests would have to be changed. A lot of code would have to be rewritten. You know, it was going to permeate everything, and it did. Believe me, it did. If you look at the merge and all the work that went into this feature, it was a lot, and I'm glad that the result seems positive. So with that in mind, I want to go through essentially what changed with this new version of rocks. I think the easiest way to see this is by looking at a test that I wrote. And you could look at any of the tests, doesn't really matter, but this is just one that I think shows what is different now in rocks. So the first thing you'll see is that there are now attributes. So you no longer say rock.create. And I have to admit, from a coding perspective, this does feel a little bit awkward at first. I have to admit that. I relaxed this. I was originally just going to say do it on just assembly, but you can put them on types, classes, or methods. And you would typically do that for a test class, not on the, I want to be clear, I don't mean you put that on the type that you want to mock, because you may not have ownership of that. That's not what I meant. I meant like you just put it on an arbitrary class. Typically, you'd probably do that on a test class or the method itself. It doesn't matter. At the end of the day, the generator will get a summary of all the attributes you put in, and I will only generate, for example, in this case, one mapping or mocking infrastructure for this. By doing this, this is kind of following what I've been picking up on is the, I don't want to say right way, but I think the preferred way of doing source generators is have an attribute trigger your source generator. I'm still not quite sure why, other than I've heard that that's been highly optimized to find all your attributes right away. I think, I'm not sure, but I think that's what they're saying. So I'm like, okay, I decided to change to that, but not because I wanted to move to attributes per se. What I really wanted to do is what you're going to see down below. I started to think the code that I was originally generating had a ton of casts in them. And I thought, if I remove those casts, could I make this so that it would be more efficient? There'd be less memory consumed. There would be better performance. And some initial testing that I did showed that. And so that's what I was driving towards is, oh, if I do all this work underneath the scenes, then you'll have a mocking experience that will be even faster, which I'm like, that. I like saying that. That makes me feel good. But a consequence of that was, well, you would create a type of this, and there would no longer be extension methods. There would no longer be an arbitrary way to make a new expectations class. I thought, well, I could have rock.create based on the name of the type given that would create a string type name, and then just assume it could create that here and then move on from there. That felt really ugly. I didn't want to do that. So I said, okay, if you put one of these attributes in, then there's a class generated with this name, and that's what you new up, and that's what you use from that point on. Underneath the scenes, if you're interested, what I do is for each member that can be handled, for each member that can have an expectation set, there are these handler classes that are made that basically capture all the arguments. The base handler types have the expected call count, the callback, things like that in place. And even though these are public properties that are settable, these are internal to this type. So you can't actually see them and you can't get access to them. So things are still controlled. I create a list for each one of the handlers. And then in verify, I just have a method that will go off and say verify the expectations that were in each of these lists. The mock name is now just mock all the time. You can't see it anyway. And that just made things a little bit easier and consistent. A lot of naming has been a little bit easier for me to read just as an author of the generator now. I used to have some crazy names being made and I went, nope. I'm going to standardize on a lot of these things now. And that's made things a little bit cleaner. A lot of the implementation of these methods or the members is the same, other than I could be a little bit more efficient. I can go directly now to the handler, get the count. If there are some, I can just do a for each. I can access each of these directly and I don't have to do casts anymore. That's a big one. That's really the whole reason I did this. And this is now more efficient. So yeah, a lot of this stuff just drew right from the implementation here and saying, could I do this? Yes, I can now rebuild all the infrastructure around it. The expectation types underneath the scenes are also much simpler now to manage. And what this all gives you from an experience of using let me go into my integration tests here. Let's just I'm going to pick a simple one. Let's do return with events. Why not? And you'll see here, I new up the expectations. I'll say methods dot. There is no extension method here. I find this to be cleaner to use. It just feels better because there's not all these extension methods everywhere. I have this is saying I want to call this method, has no parameters. And then I'm going to raise my event. These are extension methods that are still made, but they're made because of a convenience in the fact that I'm not making custom expectation classes anymore. So I tried to not have these in place. I rewrote the tests and went, oh, that's ugly, because you have to do add raise event and then give the name of the event. And the whole reason I made these extension methods in the first place is because I think it read easier when you did this. So I put them back in, and you can still do it by saying add raise event with the name of the event as a string and the event arguments, but highly recommend you do this because it's so much easier. And then everything else is the same. I do put on these tests which types I want to have mocked, but again, I do it here and I do it here. Just one of these classes is generated. So again, nice thing to have them in place. And I tried to do the thing with custom pointer types and custom ref struct types for span and read-only span. And I went, I spent a lot of time on this. In fact, my third try at pointers almost worked until I ran into, where is this? Let's go down here. Pointer generator tests. I found one in one of the NuGet libraries I have in my code generation test console application that actually had triple pointers. So I was just like, okay, double, triple, quadruple, you can go as much as you want. This was the actual signature that I found. And I'm like, that actually just messed up everything I was trying to do. I couldn't handle this in a, for lack of a better term, generic way. And so I said, screw it. I'm just going to keep making these projection classes. And yeah, you still see some of these with the hash code after it because it's just easier to manage. But a lot of this stuff also just becomes easier to manage from code, from at least the code that I wrote to generate all this code. So supporting pointers and ref structs is still there, but I couldn't do it generically for pointers, and I couldn't do it consistently for ref structs because I would only be able creating them for span and read only a span. And I'm like, I don't want to have these conditional cases, either just do it one way or the other way. Now, ref structs may get support in generics in the future in C#. So with those, I might be able to create types that can handle that generically, but for right now, I can't. So, but this is the same case that I currently had with rocks, and it's fine. Because most of the time, I mean, with span and read-only span, that's the only one that I thought people are using more, and they may show up in types that you can mock more, but pointers definitely aren't. Unmanaged function pointers aren't. Those are pretty rare. They happen, but they're rare. So I said, okay, fine. Just keep doing it this way. So yeah, at the end of the day, there was a lot of code that changed, a lot of things some things that went away, some things that got easier to do. But once I finally got to the point that I did today, which is I published the first alpha version of this, I went into benchmark mocknet, and I had talked to Steve. He's the one that owns the repository. I asked him, how do you want me to handle this? Because this is going to be a breaking change, and I don't want to throw it on him. He said, just fork the repo, make a PR, and I'll eventually merge it in. I said, cool, I'll do that. I wanted to do it locally too, because that way I can get some data on just what are the changes, and how, in terms of performance, how much better does it get? And so what I did is I ran the benchmark mocknet tests, and I did it first with what I have with 7.3.0 and got the numbers that way. And then I did it with the 8.0 version. And there are two things that got a little worse, and I'm going to talk about that in a second: the construction and the verification. Everything else after that, though, got better, even better. It's already was the fastest one, but now it's even better. So for example, like having a return, and really want to look at the ratios, not the numbers, because those can vary a little bit as you run it. But before, the ratio for the execution time was 25, and now it's 15 compared to the baseline, which is the stub. The memory allocation was 28, and now it's 18. So that just shows that by removing the casts, by having these properties available, accessing them directly, so on and so forth, that definitely helps. If you look down at like a one parameter one, and let's move down here. So originally it was 24 and 33, and now it's 17 and 21. There's going to be some point where I just can't squeeze out any more memory or make it faster. I think I'm getting to the point where if you want to have a mocking framework that actually does what you want to do, which is to have expectations set up, have it run, and then verify it. I'm open to ideas to make it even faster, but I'm at the point right now where I don't think I'll ever go through and do a change that required so much of this to change. And I'm still not done. I'll get to that in a moment. I'm still not done. There's some things I have to do to finalize the 8 release of rocks. But this much effort, it's getting to be the point where I'm like, I just don't really want to spend the time anymore to, if I could get this to like 50 nanoseconds, that'd be cool. But I sit there and I go, I don't know how I could do that. I'd have to really start looking at these method bodies and going, is there any way to make something like, let's go back up here where I do have one. So for example, a method body like this, where it kind of has to do what it's doing and make it any faster. I'm not sure, but I'm still very happy. I want to be really clear. I'm still very happy that the results showed that yes, this effort was worth it. It definitely, you look at something like just a simple return test where it was almost 400 nanoseconds, which again, that's fast, but now it's 217 nanoseconds, and the ratio to the baseline went down and the memory allocation was less. And I think I can do that even a little bit better. I know I'm going to get to that in a moment, but just wanted to clarify that I am happy with the design and the changes that occurred. It is a breaking change, but at the, you know, at the end of the day, so few people use this library that at this point, I don't mind doing these kinds of changes. If for some reason lots more people started using this library, then I would have to be more concerned and cautious about doing a substantial breaking change. It really isn't, in the sense that you only have to change like those extension methods where they're now properties. I did change some names where you say returns, I say return value, expected call count. There are a couple things that changed there too, mostly because I wanted people to be like, yeah, change this. But overall, it's better design. I do like it overall, and I'm happy with where things have landed with this. That being said, there's still some changes I have to do to get a final release of this done. And I need to get this done because, again, I've got a VS Live coming up in Vegas in just over a month, and I do have to start prepping for that. There's a couple of newish talks that I'm doing, and just make sure that I'm prepared and ready for things. So there's that. But I think I can get all this done before that. The first one I mentioned already, that's just updating benchmark mocknet. You saw the numbers that I gave before, and once a final release is there, I'll make the draft PR become a full PR, and then hopefully that just can be accepted and the new numbers can show up. Artifacts usage is just something that there's a new way to say in .NET 8 for your projects, the outputs of a build go into different folders. And I like this approach because you get an artifacts folder that has your bin and your obj and your not packages, but there's another folder underneath there that will have your NuGet packages that you create there. It feels cleaner. It feels better than just having a bin and an obj folder directly in your project file. So this should be a small one, but I want to put that in. Diagnostics analyzers is another thing that needs to happen. I changed my Rocks infrastructure to have my own immutable read-only models. I did that a little while ago, which is the right thing to do. But what I kept hearing in some of these Discord channels is you really should not be doing any diagnostics in your code. And I thought, well, why? Finally realized, let me get into my code here. I finally realized why this is a problem, because the only place you can report them is here in your callback to register source output. Well, that means you have to have your diagnostics in here. And that means that your immutable model may change as the generator runs incrementally. And that's not a good thing. So that literally just dawned on me. I'm like, why do you really need to do this? I'm like, oh, now I get it. Now I understand why, because that has to come through to this point, and then that messes up the generational incremental aspect of things. You really want what comes out of these calls here to be literally just your models, just your stuff, not even the diagnostics. You don't want that in there. But then I thought, well, that means I got to make my own assembly and I got to have two of them. I got to do packages. No, you can actually have your analyzers in the same project. And I've done a lot with analyzers before. So it's going to take a bit of work and a bit of reshuffling. But basically what I'm going to do here now in the generator is, instead of, like, if it does contain diagnostics, then I'll just return null. And then down here, I'll have something like, there should be like a select or a select many or whatever. I'm going to have to change that so that I don't, oh, is it here? Could I do that? No, wait, what did I just do? I think I could do something like is not, no, I can't remember. I used to do this in Rocks before. And that's a list though of things coming out. So again, I don't want to solve it here because that's not the point, but I basically don't produce one if there are diagnostics. And then the analyzer would do the same thing and basically then just report them for all those attributes. And I think that's going to be the right approach. So that's something, it really shouldn't affect people using it, but it will make the generator even that much better. Open generics. This is an interesting one. Let me actually get to the issue because I have a piece of code there to show this and zoom this in a little bit. Okay, so the way I've always done this is that you had to close the generic. So if you have a generic like this, generic type, you had to create it like this. Well, I think the reason why I never supported open generics was in part you couldn't define that here, and then you'd have to have a type of or whatever. But with the names that come out of things, I was just like, I'm not liking this. It would have been hidden this way, but I'm not liking this. I don't know if the changes I made in 8 are going to facilitate this or not, but what I'm thinking is have another version of the attribute where you pass in a type, and I think I'll be able to grab the type here, and then I just tweak some code that I generated to show, yeah, you could now have an open generic here, and then you pass in the values here, and then you could have it where the two values are reversed and the type values are reversed. And then you just have the generics right here on the expectations, and on and on and on. It trickles all the way through. So I did this, and it works, like in terms of just a modified code example of what my generator does right now. So I'm thinking I might want to do this, and we'll see how easy or how hard this will be to do. But I would, if I can get it to work, I would actually recommend to people use this. If you are mocking a generic, I think that's the right way to do it, and actually don't close it by passing in the specific types. Keep it generic the way it is defined. So that will be, I think, a cool one if again, I can pull it off. And then the last two are related to performance. Again, this illustrates why, one, testing is good. I say this all the time. Testing helps you find bugs. There is no way I could have done all these changes without tests. Absolutely no way. It would have been a nightmare to try to make this change. In fact, I think it just wouldn't have happened. It would have been infeasible. So tests are good. But also this is showing me that having performance testing is good as well, because this actually showed me two things that I think I can fix. I'm going to talk about the second one first, which is the expectation constructor. If you look at, where can I do this? Let's go into some generated code again. So where is this? Yes, here. So in the expectations, I create a list for each one of the handler types. And if you notice, I'm just saying new. Well, the default for a list is to create a 4-element array underneath the scenes. If you actually look at the list, in fact, let me bring that up in source.dot.net. So you'll see here that a list, again, is just a wrapper around an array, and then it also has the size here. And if you create a new list, it's initially empty and it has a capacity of 0. And then when you add the first element to it, okay, so this actually, now that I read this is good that I'm reading this. It will change it to being a default capacity. So that's actually interesting. I did not realize that. So for every new list, it actually has no elements in it. So maybe this isn't the change that I think could make this a little bit better. What I'm getting at is, if you look at the construction result, it was ratio of 3, and now it's a ratio of 6, and the memory shot up. Now again, we're talking 144 bytes to 288 bytes. It doubled. And that may be just because I have separate lists now, where I used to just have one list. That might be the case. So it's possible, and that might just be something that's a consequence of having each of these handlers in separate lists now. So that one I may not be able to fix, but this one I've always just been kind of like, it's not that big of a deal, in my opinion. So, maybe I lazily allocate these, but that might actually end up causing too much performance issues at the end of the day. So this one honestly wasn't the big deal. The bigger deal was this one down below, which is verification. It used to have a ratio of 35, and now it has a ratio, it's 16. I'm sorry, 54. Yeah, that was like, no, it wasn't 16, it was 54. It basically almost doubled. Now it's still the fastest, but it's not as fast as it used to be. It actually got worse. And I was like, ugh. The allocation 1.7 kilobytes. It used to be 760 bytes. So that went up. I'm like, what's going on there? And so I think what the problem is here is if you look at the verification code, you notice that it just passes these in. And for benchmark mocknet, the target type has like 6 members. So there's 6 of these lists that are made. But realistically, well, with those tests, you usually only have 1 or 2 expectations being set. And so what I'm thinking is, what I could do is just put an if check around these. If that handlers list actually has something in it that means that an expectation was set, now verify it. And so for like the 5 lists that don't have anything in it, you never do an add range. You never call verify, and that would help just a little bit in terms of not doing as much work. We still have to do an allocation of a list, and we still have to do the verification exception if there's one there that we can't get around. So, but I think that might help. So that's another change I'm going to put in and see what that does. Again, with doing some performance checking to see, yes, is this real? That's my gut is telling me that's what's it's going to help. But I really don't know if it's going to be something that will make it better again. We'll see. I don't know. So that's all the work I've been doing in Rocks. Again, a lot of effort was put into 8, and I'm very happy with the results. Some things still need to be tweaked, but I think I'm on the right path, and I'll probably do some episode recording tomorrow, just doing a couple of these things like with artifacts and some of these changes. Changes like this, putting an if check around these when I generate the code. The problem is that it causes a whole bunch of tests to fail because it doesn't match the diff. And so then I just have to spend like 20 or 30 minutes, however long it is, just to go through all those tests and change them so that they have the new code generated. And that can just, it's more time consuming and annoying than it is hard. So, but again, worth it because tests are important. So, but I'll probably do some more recording in the near future, get some episodes done on this. And once 8 is finally done, then it will be finally time to move on to something else and see what else I have in store and on my list of things to do and talk about, and start doing some recordings with that material. Thank you all for watching. Leave comments and questions below. See you in the next episode.